Okay, everyone, let's get started. Sorry for the issues with the display. Okay, so today's topic is how we evaluate the output of text generation systems. So this week will be the final topics covered on for the midterm. So next week is the midterm. Next Monday will be a review for the midterm. So today after class, I will post the the exam solutions for last year as well. So you should have, a huge amount of problems. Well, huge, like, I don't know, maybe 20-ish problems to look at and prepare for. But again, the content of previous exams is not a guarantee of what will be on this year's exam, especially with the new advances in NLP since the last time that this course was taught. So again, I would encourage you to focus your studying on understanding the concepts that we've discussed throughout this class regarding things like, the transformer model, the different objectives that you can place on top of a transformer, like masked language modeling, or make sure you understand the different types of models, architectures that we've discussed, like encoder, decoder, or decoder only, or encoder only, and what each of these is capable of, and when you would use any of these for a particular problem. And finally, we talked about aligning these models to human preferences, and this week we'll talk about evaluations of their outputs, and also on Wednesday we'll talk about some newer prompting strategies, and also how you can hook up these language models to external tools or APIs to further condition their outputs on and improve their functionality, so you can make them like issue commands on top of an existing API and have them do tasks for you. So after this week, we won't cover any more topics that will be on the midterm. So your studying should focus on all the materials from the beginning of the semester up till Wednesday's lecture. Okay, any questions on the midterm? All right, great. So let's proceed with our topic for the day, which is evaluation. So this is another topic that we've kind of punted till now. We've just sort of talked about perplexity as the only evaluation metric for a language model. But perplexity is not a task-specific measure, right? It tells you generally how good is the language model at measuring the probability of some held out data set. But it does not tell you, for example, how good is the language model at translating a piece of text, right? Or summarizing a piece of text, or if you ask the language model to produce like an open-ended completion, like generate a story given this prompt, right? How do you evaluate that? Maybe the probability of the story is not a useful measure because there's so many plausible stories. Maybe we need some other type of way to evaluate the output quality. So evaluation is an increasingly more important topic as the power of these language models grows, right? So in the past, there were very clearly defined generation tasks that NLP researchers used to work on. There was like translation, and you had, some huge number of researchers working on this topic. There was summarization, and there wasn't much else. There were well-defined metrics to evaluate success on these two tasks. But, since the release of a model like ChatGPT or GPT-3 or GPT-4, actual users are leveraging these models for, completely different tasks that haven't even been studied at all in the research community, which means that we don't know how to evaluate many of these tasks. And so as the models continue to grow in their capabilities, people are now working on evaluations that can kind of scale to to kind of quantify some of these new capabilities. So today we will spend quite a lot of time talking about some of the older standard evaluations, because they are useful in kind of understanding how you might want to evaluate a very constrained task like translation. And then towards the end, we will discuss some of the newer methods that people are using to bypass limitations of these existing approaches. So we'll talk mostly about machine translation evaluation for the first 3/4 of this, or maybe first half of this lecture. Then we'll switch over to human evaluation. So what do you do in cases where an automatic evaluation metric is not well defined for a task? How do you recruit and train humans to give you useful feedback? And finally, we'll look at using large language models like GPT-4 to automate some of that in-depth evaluation. Okay, so these machine translation slides were made, I think, around 2018. So what they show is the quality of an MT system about 5 years ago. Now, if you put this passage into something like GPT-4, you would probably get a far more fluent and faithful translation. But this is good for demonstration purposes of what we're going to be talking about regarding evaluation. So here, let's say we want to figure out how good a machine translation system is. So this means, is the translation, the translated text, does it cover all of the meaning in the source sentence, and does it do so faithfully without omitting things or mistranslating things or hallucinating or making up facts or things that are not present in the source language? There's also other things, right? You might want to preserve the style of the source document or the formality level or other properties of the text that are kind of not specific to the semantics of that text, the meaning of the text. So here you can see this English translation is not very good. It says up to now the country's 224 prefecture level and above cities were identified to confirm the black and white water 2082. It's not really clear what that means, or build a separate city to solve the basic black and black water. Not clear what that is either. However, some language pairs, the translation quality is very good. So you have this setting where, for example, Chinese or Japanese to English is even the state-of-the-art MT systems make a lot of errors. But French to English, it is actually quite hard to spot errors that are made in the translations. This is for a number of reasons. So we have, for example, millions and millions of parallel sentence English-French sentences. And the languages are not as far apart as, for example, Chinese and English or Japanese and English, which use completely different scripts and have different linguistic properties, right? How much information about, for example, pronouns or gender is encoded into the language versus made explicit or relying on context. So you want a metric that can kind of capture the quality of the translation across many different language pairs. So it shouldn't be just specific to Chinese to English or English to French or something like that. So if you wanted to devise an evaluation for machine translation, first you need to think about what is it actually good for, right? Why do people use machine translation? So a lot of the time it's because the reader wants to know what is being said in this source language that they don't understand. So they want to know the content. In this case, it doesn't really matter if the translation has some minor errors, because they're more focused on learning what the content is. They're not trying to, derive some enjoyment or whatever out of reading the translation. So this use case of assimilation is still the focus of majority of research, although this has been shifting as these models grow in their translation capabilities. Another case is communication. So here, the quality is kind of paramount, right? Because if you are communicating with someone in a different language and neither of you speak the same language, it's very important that the translation system is remaining faithful and is very accurate. Otherwise, if it, for example, negates something critical on accident, this could dramatically change how this conversation ensues. Regarding communication for translation in particular, there's a very interesting use case of simultaneous translation, which is what you actually need in order to have a seamless conversation with someone else who doesn't speak the same language. So in simultaneous translation, I would be talking to someone, and as I talk, a translation is provided to the other person in real time. So at the time I finish talking, they will have understood everything that I've said and can kind of immediately reply. So in standard machine translation, I will say something, then the machine translation system will process what I've just said and generate a translation, and the person I'm talking to has to wait for all of that to complete before they can read it and understand it and then respond to it. So simultaneous translation is an interesting kind of side note, because it requires the system to not only understand what I've said so far, but also predict what I'm going to say in the future in order to make these rapid decisions on how to translate the sentence. So we're not going to talk about evaluation in that case, although as you can imagine, it's probably much more complex than evaluating a single complete translation. And finally, we're still not close to the dissemination stage with machine translation where, for example, I want to translate an entire book that someone has written into 300 different languages and then publish those translations. Right now, that process is done by expert human translators who are not only fluent in both of the languages, that the source and target language, but are also trained in the act of, for example, literary translation, which is an art form. So it's a highly specialized skill, and interestingly, models like ChatGPT and GPT-4 are useful to kind of help these translators get a first draft, but they still have to significantly edit. Not for so much for things like translation errors, but rather for stylistic consistency and very complicated semantic meaning that is being expressed incorrectly. And it really depends on the language pair as well. So low resource languages for which there is not that much text on the internet, still we don't have good systems to translate because, as you know, large language models require a ton of data in order to operate in a reasonable fashion. All right, any questions about translation in general? Okay, I'm just going to delete this comment. I don't know what it's saying. All right. So let's get to evaluation of translation. How good is a translation? The biggest problem with this task, and of any generation task, really is that there's no single correct answer, right? So given this sentence, I could translate it in many different ways, and these are all paraphrases of each other, right? Israeli officials are responsible for airport security. Israel is in charge of the security at this airport, blah, blah, blah. I could rephrase this many different ways and convey roughly the same semantic meaning. So should I get points for this one and not get points for this one if I produce it? Probably not, right? You want ideally a metric that can score the translation and kind of be robust to different rephrasings of that translation. However, like one of these translations might be more faithful to the order of information in the source text, and perhaps you would want to score that one higher. So I should also note that in this lecture, we'll be talking about sentence level translation. So one sentence in the source text to one sentence in the target text. And this was the focus of most MT research for multiple decades, although now with GPT-4 there's no such boundary between sentence and paragraph or document, and so a lot of people are using and evaluating these large language models for document level translation. Okay, so let's think about some evaluation metrics. So one obvious way is to ask humans who understand both languages, how good is this translation? Like rate it from 1 to 5, right? The problem is that this, as with any human evaluation, is subjective, right? What does a 1 mean, or what does a 5 mean? Can you specify each point on the scale in such a way to remove the subjectiveness of the task? It's very, very difficult. And some of you might agree that something is a 4, some others might agree that this is a 3, and it's unclear how to get reliable judgments in this case. Nevertheless, people do extensive training on these annotators to make sure that they roughly are on the same page, and then they will ask them to rate these translations. I think the state-of-the-art translation evaluation data sets ask humans to rate a translation from 0 to 100. So this is like a very, you can do 78 out of 100 or something. But it turns out that this method actually reduces variance. So there are two metrics that people are interested in regarding translation. One is adequacy. So this is related to the meaning of the translation. Like, does the translation convey the meaning of the source sentence, or does it omit things or add new things or distort things? And the other one is fluency. So is the translation grammatically correct? And fluency is not really a problem with models like GPT-4, but it was a big problem for older machine translation systems. And you can even try out Google Translate. It will give you disfluent text for many language pairs. So as I was saying, you can have a scale like this and tell your human translators who are rating these things to use this scale. So for adequacy, you can have a 5 be almost perfect and 1 be these two sentences are completely unrelated. Fluency, flawless English to incomprehensible. So, and you have some sort of interface that does this. I just want to try in this class, let's see if we can come to an agreement on whether or not these sentences are fluent or adequate given the source sentence. So I'm not going to read the source sentence, but the reference translation, so the reference means this is the gold translation that an actual human has produced, is there not an element of hypocrisy on your part? So now we have 3 systems, and each one has produced a translation of this sentence. System 1 says, would it not as a wave of hypocrisy on your part? So let's rate this in terms of adequacy from 1 to 5, where 1 is bad and 5 is fully adequate. How many of you, just raise your hand, would give this a 1 out of 5? Like, does it preserve all of the meaning from this reference sentence? Sorry, does it preserve like none of the meaning at all and is completely unrelated to this reference sentence? Raise your hand if you think it's a 1 out of 5. All right, what about a 2 out of 5? Okay, so maybe like 20% of you. What about a 3 out of 5? Okay, 4 out of 5? And 5 out of 5? All right, so most of you were within the 2 to 3 range, but as you can see, the class was roughly split. Let's do another one. Is there would be no hypocrisy like a wave of your hand? How many of you think this is a 1 out of 5 in terms of adequacy? All right. How about 2 out of 5? Okay, I'm just not gonna, I think that was the whole class. Let's also rate this one, is there would be no hypocrisy like a wave of your hand, in terms of fluency, where 1 is completely incomprehensible and not grammatical, and 5 is totally fluent. If you think this is a 1 out of 5 on fluency, raise your hand. What about a 2 out of 5? 3 out of 5? 4 out of 5? So again, like, we got very little agreement. I mean, everyone was roughly between 1 and 3, but you know, it was pretty evenly split. So, you know, you can see how this is maybe not the best way of obtaining judgments. Now, granted, none of you is, well, I shouldn't say that, but probably very few of you, if any, are expert translators and fluent in both French to English and have been trained in these scales with many, many different outputs to calibrate your ratings. But still, even if you were, there is some variance in any sort of human evaluation. There's a subjective element, like what do you consider incomprehensible might be different than what someone else considers incomprehensible. Okay, so I think I just covered this. I guess there is another issue of doing these evaluations using humans. Does anyone want to point out, other than the subjective nature of the task, any other issues?
Well, it would be extremely expensive to get.
Yes, this is the main other drawback, is that it's expensive both in money. You have to pay the annotators. If you're hiring professional translators, they have quite a high hourly rate. And secondly, the time, it's expensive in time, right? Because you need people to actually read these and make these judgments. And you know, additionally, you might want to obtain some feedback, like, why did you rate this a 3 out of 5 instead of a 2 out of 5? If you want that, that's even more time consuming. So you're probably not going to be able to like obtain an evaluation for thousands or tens of thousands of outputs in a reasonable time period unless you have a lot of money. So people really like automatic evaluation metrics for this reason. So in an automatic metric, you have a computer program that is capable of making these evaluation judgments for you. And you don't need to pay it, obviously. So you can just run it over the translation and the source sentence and the reference sentence. It'll output a score, and a system that has a high score is preferred over one that has a low score. So the basic strategy for this kind of automatic evaluation is you're given the output of the translation system. You're given a human reference translation that the human wrote. So in this case, it would be this reference sentence here. And sometimes you're given the source sentence as well. And you're asking the model to essentially compute the similarity between the reference sentence and the the translated output sentence. Yeah.
This processing is almost a little bit recursive. So I figure to compute the similarity between these two, you're still trying to encode the semantic meaning of like the French sentence and compare that to the semantic meaning of the English sentence, which is effectively doing the translation again.
That's a good question. So I think your question basically boils down to, if you have a computer program that can evaluate whether a candidate translation is a good one or not, then that evaluation should probably be used to help the program generating the translations in the first place, right? So there are a couple issues with that, although in principle you are somewhat correct, and in fact this has happened where people use these automatic metrics to further improve the original translation system. But as you'll see, the way in which we implement this program is extremely simple compared to the method that we have talked about for translation, which is, you know, like a encoder, decoder, transformer model, right? This requires training on, you know, many examples of French, English parallel sentences. It requires backpropping through this huge model and applying a decoding algorithm. As you'll see, evaluation doesn't require any of that. It just requires having, you know, 2 sentences and doing a simple comparison. And it'll be more clear when we talk about the first method that this task is much simpler than the generation task, at least in the way that it's set up here. But you can make it more and more complex. Like, you can make the evaluation metric more powerful And in doing so, it will start to resemble like an encoder of the encoder-decoder model that has been fine-tuned for evaluation. And then you can imagine using the metric itself to form a reward signal and further tune the translation system, like when we talked about the RLHF in large language models. Okay, and I see this person has a similar question. Can we use LLMs to estimate similarity between two sentences? Yes, we will get to that in a bit. But first, we're going to talk about some very simple approaches to measuring this similarity, which amount to basically computing the precision and recall at the word level between the candidate translation and the reference translation. So if you take this, the system should have produced Israeli officials are responsible for airport security. But the system actually produced Israeli officials' responsibility of airport safety. So it gets some of the words right, but it's clearly not fluent. It's not grammatically correct, right? So one simple way to measure the similarity is just to do word matching. So if you wanted to compute the precision, you would see how many words in the candidate translation also occur in the reference translation. So this is just doing a word overlap, right? So 3 of the 6 words occur in the reference, and so the candidate translation has a precision of 50%. The recall is similar, except you're now counting how many words in the reference translation occur in the candidate translation. So you have a different denominator in the calculation, and the recall is 43%. And then you can kind of compute the F-score using both the precision and recall if you like. Okay, so what are some limitations of this approach? Exactly. So I could have said airport Israeli officials safety responsibility of, and I would get the exact same scores, right? Because I'm not considering the word order at all. Yeah.
So it'll give a high score for some particular translations, but a lower score for other words that maybe use, or other sentences that maybe use synonymous words.
That's right. So it has the issue with these paraphrases, right? So if I said instead of officials, I don't know, like, what is a synonym for officials? Something synonymous with officials, right? I would get penalized for this even if it means the same thing. And this is the same issue that we talked about with N-gram models coming back again, right? Instead of looking at the exact identity of words, maybe we want a soft kind of vector-based similarity. But in this approach, that's not present. Any other issues?
So if you have very short sentences, you get high precision, so system labels all the words in the vocabulary to get
Sure. So if we had a very, very short translation, maybe we always spit out the word the, right? The occurs in a lot of sentences, so we might have a high average precision, even though the translation itself is not meaningful. That's a great point, and it is encoded in the metric that we will be talking about in a couple slides. Yeah.
So one of the issues is that the hypothetic verb has a pattern, and we can measure that if we can change the pattern to get activity to that.
Yeah, so this is similar to what he was saying. Like, for example, if you said Israeli officials were responsible for airport security, but you could argue that you shouldn't get points for this because you actually have changed the meaning of the sentence, the tense.
The most important is the position and the order that if we change the order of the
Right. That's right. So here, again, the order is not captured at all. Yeah. Yeah, that's true. If it's more than the reference one, we still have the same issue, right? Like we, all of the same issues apply. The precision and the recall computation are the same. Yeah.
Wouldn't you still need someone to produce a reference translation to do that?
Yes, this is another great point. Like all of this assumes that we have the reference translation to begin with, but in many cases it might be expensive to gather a lot of reference translations, and maybe we would like a system that could just do this based on the source and the candidate translation. So we won't talk about those metrics in this class, but they do exist. There are reference-free metrics that people do commonly use today for this reason. Sorry, so just to clarify, the candidate translation is produced by a system, like say this is some encoder decoder model that. Yeah, so maybe I'll be clear on the setup here. Remember that in all of these kinds of problems, we have a training set and a test set. And so the test set, we have some source sentences paired with the target translations, but we have never trained our model on these sentences. So when we're talking about this reference, these are coming from the test set. So we know what the true translation is, and so we can compute these metrics. But you're right that if I wanted to use this system in practice, I'm not going to know the true reference translation. But this is just a way to evaluate on sentences that the model was not trained on. Okay, so we talked about the ordering issue, right? So here, if system B output airport security, Israeli officials are responsible, just switch up the words in the sentence, it would get 100% precision and recall and F score, despite not being a good translation. So this brings us to the most commonly used metric for translation, even today, despite all of these issues that we've talked about, and it's called the BLEU score. So basically, they get around this order, the lack of order issue that we noted with the word level precision and recall, by just computing precision at different n-grams. So you can compute precision for unigrams, which is what we just saw, or you can compute precision for bigrams, so all 2-word chunks. And they do it for 1, 2, 3, and 4-word chunks. So you can imagine if you compute precision of 4-word chunks, the order is actually important within each chunk. So you get some local syntactically valid chunks, but you can still have a globally disfluent translation. Nevertheless, this score has been shown to correlate with human judgments of adequacy and fluency, especially if you have a lot of judgments, human judgments, and a lot of translations. So if you have a large test set, you can get a very good estimate of this BLEU score, and for many language pairs, it tends to correlate with what humans think. It's not reliable for individual sentences. So basically, you have to compute the score over the entire test set. You shouldn't use it at an individual sentence level. Okay, so let's take a look at this formula here, just so you understand what's happening. The main part of the formula is this geometric mean of precision at different n-gram values. So you take the precision of all words, single words, you take the precision of all bigrams, trigrams, and 4grams, and you compute the geometric mean of these to get a single kind of average of the score. So in the original paper, they found that the geometric mean results in a better correlation to human judgments than the simpler arithmetic mean. There are several hypotheses for why this might be. For example, if you take the geometric mean, it kind of strongly favors a translation that has high precision across all of the n-gram values of n, but it's still unclear. All we know empirically is that it correlates better with human judgments. So you'll note that recall is not a part of this formula. Instead, we have this thing here, which is called the brevity penalty. So this is in direct counter to what you suggested, where I could have a translation that's extremely short and gets a really high score on precision, but it's not actually a good translation. So this brevity penalty, you can see, is just looking at the ratio between the candidate translation and the reference. So if I output the word the, I'm going to have a very, very small ratio here, which you can see this is multiplied to the precision. So it'll give me a low score, even if my precision is high. Okay. So a natural question you might have at this point is, why are we not incorporating the recall into this computation? The reason is because in an ideal case, we don't just have one reference translation, but we have multiple reference translations. So here, I might have these 4 different translations, each written by a human. Israeli officials are responsible for airport security. Israel is in charge of the security of this airport, and so on. So maybe 4 different translators have translated this sentence, and if I have multiple translations, ideally I would use all of those in my evaluation, not just a single candidate. But you can imagine if I compute recall, right? Recall is looking at how many of the words in the reference are present in the candidate translation. So it's not really fair to the system to ask it to optimize recall over multiple translations, right? That would mean to get the top score, it would have to include every single word in all 4 of these translations. So that's why instead of including recall in the BLEU score, we include this brevity penalty to penalize shorter translations, which has a kind of similar effect. Okay, so let's just take a look at how these scores are computed for the BLEU score, just to make it more intuitive. So we'll continue with our same Israeli officials sentence, but we have 2 system outputs. So one candidate translation is Israeli officials' responsibility of airport safety, and the other candidate translation, airport security, Israeli officials are responsible. So let's take a look at the word level precision first. So this is the unigram precision. We can see Israeli officials' responsibility is not a match, right? Because the reference contains the word responsible, not responsibility. Of is not a match. Airport is a match, and safety is not a match. So for system A, we have 3 of the 6 words that occur in the reference. Meanwhile, system B, it just has reworded or shuffled the words in the sentence. All 6 words in system B occur in the reference translation. So it gets a 6 out of 6. So far system B is doing great here. Now let's look at bigram matches. Israeli officials, this phrase matches exactly the reference, but you can see officials responsibility of airport safety. None of these bigrams in candidate A match with the reference bigrams. So system A gets a 1 out of 5 in terms of bigram precision. System B, meanwhile, has airport security, which does match. Security Israeli does not match. Israeli officials does match, officials are matches, and are responsible matches. So 4 of the 5 bigrams in the second translation also occur in the reference translation. Finally, we can look at trigrams and fourgrams. System A has none of either of these. System B has 2 trigram matches. Israeli officials are, and officials are responsible. And it also has 1 fourgram match, which is here. So overall, you can average all of these scores using the geometric mean. You'll find that system A gets a BLEU score of 0 because it doesn't have, it has 0 precision for trigrams and fourgrams. System B gets a BLEU score of 52. So overall, this is just a demonstration of how you might compute the BLEU score for a single sentence. But remember that it's not reliable at the sentence level for cases like this, right? If you have 0 precision on a trigram or fourgram, your BLEU score is going to be 0 at the sentence level. But at the corpus level, at the whole test set, you might still get some reliable numbers to be able to separate the 2 systems' performances. All right, What about stemming in the words responsible equals responsibility? You can use stemming, but it kind of breaks the fluency in many cases of your system. So you may not be able to properly evaluate fluency if you apply normalization to the translations. People have probably tried it, but it's not included in the main BLEU scores that people compute. Yeah.
How about compute do a subword organization and then compare the decisions?
Yeah, so that's a good point. In general, people they compute it at the word level, where you have to use a tokenizer for the language to split into words before computing this word level. But you could do it at a subword level. I think people don't do it just because the scripts that people have been using for many years all use the same exact tokenization, and they want all systems to be comparable. So if you have a system that uses subword tokenization and you want to compare it to a system that uses character tokenization or word level tokenization, right? You want your evaluation to have a unified way to split the input. So if you did a subword level BLEU score script, then you would have to make sure that all systems that you want to compare against are evaluated with the same script. So in some sense, it doesn't really matter. Like, you just need one single way that you'll split the inputs that is consistent across all systems that you want to compare to. But it's a good point. Other questions?
So we have multiple reference translations. So the unranked is every one of the reference.
So remember, here we're looking at precision. So if we had multiple references, and let's say we have this bigram airport safety, right? It doesn't occur in this reference, but it might occur in any other reference. So if it occurs in any reference at all, then we give this points, like we consider it a positive bigram count. So that's how we compute the precision with multiple references. So basically, if the bigram matches any bigram in any of the references, yeah.
So in that case, how is the brevity penalty?
Oh, so yeah. For the brevity penalty, I think you take the one that is closest to the translation, the candidate translation, or something like that. So basically you take the candidate translation that minimizes this, that makes this ratio closest to 1 when you are computing the brevity penalty. Because like, you don't want to always pick the longest one, right? That might unduly penalize the translation. So if you have a couple translations and one of them is very close to your candidate, then it makes sense to use that. All right, so again, we talked about all of these drawbacks before, and we noted that moving from word level precision to n-gram level precision does kind of reduce some of the issues with the word order not being considered, but it still considers word order only very locally. Like the most it considers is word order within a 4-word chunk. And if you have a very long translation, this still isn't that great. As we see here, like, this sentence is not fluent at all, system B's output, but it has this 4-gram match. Israeli officials are responsible, so it gets points. If it had 5-gram matches considered in this BLEU score, then this one would have a 0 BLEU as well. But you can't just keep increasing the number, because you might have some shorter translations or shorter sentences. Also, the scores are kind of meaningless. The absolute value of the BLEU score is not meaningful, only its relative ordering. So if you have system A has a BLEU score of 25 and system B has a BLEU score of 30, you can conclude that system B is likely better. But the score of 30 or 25 doesn't mean anything. Human translators also score low on BLEU. Like, the upper bound of the BLEU score is not 100%. Human BLEU scores are usually higher than that of machines, but they might be like 50 or 55, and it really depends on the language that you're translating into as well. All of these problems aside, BLEU score has been shown to correlate with human judgments in several different research works in both adequacy and fluency, which is why people continue to use it. However, people have started using it in the last 5 to 10 years for tasks that are not translation. Because as you can imagine, this is a good way, it's at least a cheap way, a very easy way of computing the similarity between two strings, right? So people have used it, for example, in image captioning. So does a generated caption match a reference caption? Or in using it for many, many different tasks, even for things like story generation, where here you can see that just having a reference story, it's not enough to match the generated story to the reference because there's so many possible acceptable stories. So using this BLEU score is meaningless in cases where you have a huge output space. It makes a lot of sense in translation where you need to produce some like very specific meaning, but it doesn't make sense for open-ended tasks. Okay, and so you'll see BLEU score a lot in generation papers. You may also see the ROUGE score, which is very related to BLEU, except it considers precision instead, it considers recall instead of precision. So ROUGE score is generally used to evaluate text summarization. So in text summarization, your system gets a big document as an input and it produces a summary that might be like a paragraph long. And to evaluate, you might also have a reference summary that a human has written that contains, you know, the most important parts of this document. So remember that if I'm computing the recall of the n-grams in the candidate text, I'm looking basically for all of the n-grams in the reference summary, how many of them are present in the model-generated summary. So why do you think we might want to use recall for the task of summarization rather than precision? So can you expand on that?
Like whatever generated text we get, it should have same amount of similar meaning as the reference text.
Yeah, but maybe a more specific answer for the task of summarization.
Much like one of the tasks one of the problems we talked about earlier this semester is that with summarization, ideally all the information, the proper answer to the task should be within the provided input. If we're giving it, here's a paragraph, summarize it, ideally all the information the summary would carry is already found within that paragraph. So for the purposes of recall, that's we want to match specific words of the output. The ideal output would contain a lot of information based on what its input is. So ideally, we want those to match almost one-to-one. Saying it's using information specifically from the input and just taking.
So remember that when we are computing this ROUGE score, we have the model-generated summary and we have a human-written summary. So we're not actually using the document at all in this, although that is a good point, and several papers have looked at what if instead of using the human summary, you use the document itself. But the canonical way to use this ROUGE score is you have a candidate summary, you have a human written reference, you compute the recall, so the percentage of n-grams in the human written summary that occur in the generated summary. So any other ideas on why? That's right. So the content of the summary is very important, right? And specifically, the human written reference contains all of the important information in the candidate in the source document, right? So it has ideally the ideal summary would include as much of that important information as possible, and it's fine if it includes other pieces of information, right? That's not as big of a deal as including as much of the important information as possible. So in translation, like, you need to preserve the meaning of the entire human reference translation, right? So this is a different case in summarization, where it's a little more like you want all of the important information to be preserved, but possibly it can produce other things that are maybe slightly less important and still get points for this. So yeah. Okay, so now let's move on to what is a very natural question that several of you have raised is, why do we have to do this when we have these powerful encoder models? Like, why can't we just learn an evaluation metric instead? Okay, let me just see these YouTube comments. Is there a specific data set that must be used to obtain a BLEU score? No. So yes, you're correct that any machine translation data set, held out test set can be used to, or dev set can be used to compute BLEU score. What was the question? Oh, this was the, okay, thanks. This was answered. Not sure if heard correctly. The BLEU is a poor metric for open-ended generation due to the large solution space, but is often used anyway. Yes, it's a poor metric, and people use it even though they shouldn't use it, and you should not use it either. It's used often because people don't know how else to evaluate their model, and they don't want to take the time or expense to do a proper human evaluation. So you should never use BLEU for an open-ended generation task. It just doesn't make sense as a metric. All right, so now let's talk about the cleverly named BLERT, which kind of takes BLEU and makes a version of it that incorporates BERT, an encoder-only transformer. So essentially how BLERT works is we take the pre-trained BERT model, right? So BERT is an encoder-only transformer that is trained with a masked language modeling objective. And we first fine-tune it on several synthetic tasks. So for example, you might have a sentence and you perturb it in some way, like you drop some content from the sentence, or you shuffle some content from the sentence, or you do all of these different things, and you ask the model to see if it can detect what kind of perturbation has occurred, or how severe this perturbation is. So these kind of perturbations are mimicking some translation errors that commonly occur with the MT systems that we have. At least this was two years ago. With these large language models, the types of errors that are being made has also changed dramatically compared to previous systems. The most important thing is this last bullet. So you have your model, you've fine-tuned it on several different synthetic tasks, and finally you take a large data set of human judgments about translation quality. So like those adequacy and fluency scores that we did by raising our hands, right, the 1 to 5. They take hundreds of thousands of these judgments from people that have rated translations, and they fine-tune their BERT model to predict the score given the reference translation and the candidate translation. So essentially, this evaluation metric is directly learned to predict human judgments. It's not like BLEU, where we're computing some basically stats on the word overlap, right? And somehow it magically correlates with human judgments. Here, we're training a model to directly predict human judgments. So yeah, this approach allows us to leverage a lot of the pre-trained language model, the parametric knowledge that we have in BERT. Yeah.
What can the perturbation involve? Can it involve like changing words, or could it involve just perturbing the bag?
Sorry, the perturbations all involve the input. So the actual text gets perturbed. So you can drop a word in the input, or you can replace a word with a synonym, or negate something, or drop an n-gram or something like that. None of the perturbations happen in the embedding space. That would be interesting, but it's not what they do here. Okay, so with a model like BERT, eventually its score is kind of normalized within 0 to 1 or 0 to 100 range. And again, just like BLEU, you should only be interested in the relative ordering of systems via the BLERT score, not the absolute score. So there's BLERT, there's an alternate called COMET, which does something very similar, except it doesn't do any of these synthetic tasks. It just directly fine-tunes a BERT model on human judgments. Both of these are very good. You can imagine that the human judgments might be collected only on a limited array of language directions, like source to language target. Like it might not be, you might not have data for, say, Polish to Japanese translation, but you might have judgments for English to Japanese and Polish to English or something like that. So in order for these kinds of learned metrics to generalize across many different languages, what they do is they start with a pre-trained multilingual model. So there are things like multilingual BERT, which have been trained on many different languages at once, not just English. And then they will fine-tune this model on all of the human judgments that they have. And even if they haven't observed, say, Japanese to Polish translation before, people still use them, and they seem to be somewhat meaningful for these unobserved language directions. So there's some generalization going on, even if the model hasn't seen human judgments for that task. Here's how COMET works. So it, again, is just using one of these pre-trained encoder-only models. So you see here pre-trained encoder. This could be BERT. It could be MBERT, which is multilingual BERT, or XLM, which is another multilingual encoder. It could be byte T5 or MT5, just the encoder part, which we discussed when we talked about tokenization. So you can see that you feed this concatenation of, so COMET additionally takes a source sentence as input. So the hypothesis is what the system generated. It's the candidate translation, the source sentence, and the reference. All of these are concatenated together into a single string and fed into the pre-trained model. Then there's a pooling layer. So pooling refers to taking all of the final layer token level representations and converting them into a single vector. So you can do like an average of all of those, an element-wise average, or you can do something more complicated like a recurrent neural network. In this case, they probably just do an average. And they have a feed-forward layer, and finally they have this square loss, which we talked about when we did backprop, which is going to predict the exact score that a human rater assigned to this candidate translation from 0 to 100. So they treat this exactly as a regression problem. Okay, wouldn't fine-tuning on human judgments require huge amounts of data to be performant, which is a problem to gather? It's a good point, but there actually is a sizable amount of human translation ratings. There's over 100,000, maybe even 200,000 or 300,000 of these at this point. People have been collecting them over the past decade, so there's a lot of data. But it's a good point because the errors that translation systems were making in 2015 are not present in large quantities now. So training on data from 2015 may not be so relevant to evaluating today's systems. And this kind of data drift issue is very important for modern metrics, and it has not been addressed yet. So it is a good question. Okay, so I had some slides on evaluating open-ended generation with human workers, but maybe I'll just go through them relatively quickly. I wanted to talk about some more recent work at the end, so I'll just maybe in 5 minutes roughly summarize how people nowadays evaluate open-ended generation tasks, like, for example, story generation. So in story generation, you have a very unconstrained task. Here you can see a prompt. You, a video game character, just died. You had no spare lives left. So given this prompt, you have to write a story. You can imagine there's infinitely many plausible stories you can generate in response to this prompt. So none of the methods that we've discussed make sense here, right? If I have just this reference story, Link woke in a panic, blah, 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 I can't really use this in any way to evaluate the candidate generation from a language model. There could be many other ways to approach this. It's not a constrained task like translation. So the evaluation methodology that people like to use is you have a prompt, you have the human written reference story, and you have a story that's generated by a language model. And now you want to kind of compare these two stories together directly, based on the same prompt, and have a human rate which one is better. And you might want to have them rate which one is better on several different fine-grained attributes, like, is this story relevant to the prompt? Is it coherent? Is it enjoyable to read, right? Enjoyability is a very important attribute of story generation, but it's also incredibly subjective, right? Like, you may love this story and I may hate this story, and we're both allowed to have our opinions, right? So the things that we want to evaluate are inherently subjective. So how people approach this problem even now is they go to Amazon Mechanical Turk. How many of you have heard of Amazon Mechanical Turk? For those of you who haven't, it's a kind of online marketplace where you can hire crowd workers to perform various jobs for you, like small tasks, like, for example, rating how grammatically correct a story is from 1 to 5. And you pay the workers some small amount for each task that they complete. So, you know, people like this platform because you can run these evaluations fairly cheaply. There's a lot of workers, and you can get things done very quickly. However, there's a cost you pay for that ease of doing the evaluation, which is the people on this website don't generally like to read a lot of stuff, and they like to do things as quickly as possible so they can maximize their reward, right, which is getting paid. It's very difficult to detect and find people who are legitimately doing the task versus people who are just doing it to, you know, get the most money in a certain time period. So this is one of the experiments that my postdoc ran. She decided to compare how these Amazon Mechanical Turk workers behave in rating these stories compared to English teachers, and see if they actually rate the generated stories similarly or not. She found that Amazon Mechanical Turkers think that the stories generated by a language model are just as good, if not better, as human-written stories, even though by visual inspection you can tell that the stories that the model generates are irrelevant, they don't make sense, they often make up completely new characters out of thin air and then have them be like important parts of the plot. No one would like to read these stories, and yet on this website you get ratings that are just as good as human ratings. So we found that they actually spend only 13 seconds on average reading one of these stories, which, you know, it's 150 words. You have to read the prompt, and there's no way you can judge these properties like coherence or likability or grammatical, how grammatical something is, in only 13 seconds. Basically, it amounts to they didn't read the story, they just clicked some random numbers and called it a day. So, you know, compared to English teachers, they found that human written stories are significantly better than these machine generated stories on every metric except grammaticality, which if you've played around with, you know, like ChatGPT, it makes sense. The text is very rarely ungrammatical, but it has more subtle issues with things like relevance or coherence. The other thing that I want to emphasize before moving on is that it is very important when setting up these human evaluations to do calibration of the scale so that all of the annotators are on the same page about what the bottom end of the scale and the top end of the scale mean. Even with English teachers who, you know, their whole job is to grade, I mean, a large part of their job is to grade text that is written by their students. They have these scales implicitly, right? But they may each use different scales. They may penalize grammatical errors differently. And so you need to get everyone on the same page. The best way to do that is just to do a kind of pilot study where you give the teachers 10 or 20 examples, you have them rate them, and then you give them feedback on, I think you know, compared, so this, your peer rated this differently than you, can you come to a common agreement on how this one should be rated? And once you have them all talk and decide, then you can proceed with, you know, actually doing the task. Okay, so that's for open-ended generation. There's really nothing better than doing a human evaluation. There's no automatic metric that is reliable for any of these properties of the text. So if you're working on an open-ended generation problem, like for your project or in the future, you need to learn how to properly conduct one of these human evaluation studies. And there's a lot more that I could say on that, but in the interest of time, I just wanted to talk about the future of automatic evaluations. So one thing that is gaining a lot of traction now is having more fine-grained feedback in these evaluation metrics instead of just a single score that tells you how good is this translation from 0 to 100 or something like that. It would be way more informative if your metric could tell you this translation candidate scored a 5 out of 100 because it had severe omissions, or it had, and this part of it was ungrammatical, and this part of it was added, but it didn't occur in the source text, right? If you could get like way more fine-grained feedback, it would be useful. So in machine translation, there's a schema of errors called MQM, which basically catalogs the most common types of errors that are made and links each one to a span of text within the candidate translation. So instead of getting a single score for a translation, instead you get these spans of text that are labeled with different error categories, and you can aggregate all of those into a score if you wish. So basically, people, instead of moving to a single score, are kind of more interested now in these fine-grained errors. Like, how often is my translation system making errors in, you know, mistranslating critical elements or adding new information? So the final thing I wanted to talk about is with the advent of things like GPT-4, it seems like we can have a lot more fine-grained and powerful evaluation of generated text. And this paper came out on, I think, like 5 days ago, 4 to 5 days ago. It's called GPT Eval from Microsoft, and they basically use GPT-4 to evaluate text that is generated by a language model. So getting to your question, this is, you know, kind of strange, right? Because you have the model generating all this text and another model giving like very constructive feedback on the text. And so linking the two certainly can improve the performance of the model, as we'll talk about more on Wednesday. I just wanted to give a quick overview of how this works. So this is for the task of summarization. In this paper, just as an example, they are just prompting a large language model to perform the evaluation. They say, you will be given one summary written for a news article. Your task is to rate the summary on one metric. And then they describe the metric. You will be rating coherence on a scale of 1 to 5. And then they explain what they mean by coherence, like what is that? Then they give it a series of steps that the model should perform in order to do this evaluation. So it says, step 1, read the news article carefully, identify the main topic and key points. 2, read the summary, sorry, one sec. Read the summary and compare it to the news article. Check if the summary covers the main topic and key points of the news article, and if it presents them in a clear and logical order. 3, assign a score for coherence on a scale of 1 to 5, where 1 is the lowest and 5 is the highest based on the evaluation criteria. So essentially what you would tell to an Amazon Mechanical Turker, they are now just telling to a large language model. And there was a paper recently that showed that large language models are better annotators of data than Mechanical Turkers. So, I don't know what that says about large language models or Mechanical Turkers, but you can interpret that however you wish. So anyway, this is the input prompt to the language model, and then you give it the full document and the generated summary. And then you say evaluation scores only coherence : and you look at the prediction of the next word. And obviously you told it to rate the coherence on a scale of 1 to 5. So you can look at the predicted probabilities of the token 1, 2, 3, and 4, and 5 conditioned on all of this text. So you can see they actually have a distribution over these different scores. So the language model assigned 20% probability to 1, maybe like 40% probability to 3, and so on. And they then just take the weighted average of these scores. So you get about a 2.59 average score of coherence when you use a language model in this way. So you can see that this method is quite interesting because the score of any given property can be computed with a language model by just describing the property and how you want it to evaluate. On the other hand, it's kind of hard to evaluate this evaluation metric, right? Like, is the model actually evaluating the coherence meaningfully? You probably have to get human judgments to validate that. But as we discussed, getting human judgments is itself hard and subjective. So I hope in this lecture it's clear that evaluation itself is an incredibly difficult problem. The kind of goalposts are changing constantly as the capabilities of the model increase. Old evaluation metrics become obsolete and new ones are still untested. So yeah, who knows what I'll teach next year. But yeah, this is important to know for now. So next time we will talk about some of the stuff that is actually included on the slide. So COT here refers to chain of thought as a prompting strategy. We'll talk about that and several other types of prompting strategies. I know most of you don't do the reading, but the reading for Wednesday is actually incredibly useful and also easy to read. It's a blog post that goes over all of the most recently proposed and effective prompting techniques. And it was written like 2 weeks ago, so it's quite up to date. So I would highly encourage you to check that out. All right, see you on Wednesday.
Thank you.
Yep.